In lesson 11-1 and 11-2, we're going to talk about parabolas. So we're going to be able to describe the transformations from the parent function by the end of this video. And given the transformation of the parent function, we're going to be able to write an equation of the function. So first, I want to talk about what the parent parabola is. So that's the most basic parabola. When you have a parent function, it's the most basic of that kind. So the most basic is y is equal to x squared. I don't write my 2's like that. I write them like this. So I don't know why I wrote it the other way. Anyways, from this equation, when I don't know what something looks like, although I do know what this looks like, I always can, if I don't know, I can make a table, pick values for x to plug in, and see what I get for y. So that's what I'm going to do here, even though we already know what a parabola looks like. And I'm going to do -2, -1, 0, 1, and 2. And then I'm going to just plug those into this equation. So when I plug in -2, I get -2 squared. That's what y is equal to, so that's 4. -1, when I plug it in, I get 1 for y. When I plug in 0 for x, I get 0 for y. When I plug in 1 for x, I get 1 for y. And when I plug in 2 for x, I get 4 for y. And then I'm just going to plot those points. So I have -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. And as you can see, this is symmetrical on both sides. It is symmetrical over the line, or on both sides of the y-axis. It's symmetrical. This point is 2 away on the right. This point is 2 away on the left. And they have the same y value. This point and this point are reflections over that line that goes through the vertex of the parent parabola. So we call this line, we call it the line of symmetry. And we can refer to it as x is equal to 0, or we can call it the y-axis. So the other important thing that we see here is this point. That is the vertex, which is a very important point of our parabola, so we need to know what it's called. And we also need to know, we need to be able to talk about it as saying it's a maximum or a minimum. And in this case, it is the smallest, or it's the lowest point of the parabola, so we call it a minimum and not a maximum. So that's the minimum of the function. Then we also need to be able to talk about what's the domain and what's the range of this thing. So the domain is -infinity to +infinity, and the range is going to be my lowest value, my minimum, is 0 for y. And then I have y's that go up to infinity. So that's my domain and range. Now I want to talk about the transformations from the parent parabola. So we talked about the parent absolute value function before, and we talked about the transformations we saw when we had extra stuff besides just an absolute value of x. So here we're going to be doing the same thing. When we see extra stuff, besides just x to the second power, we're going to be able to use that extra stuff, the patterns that we know from that extra stuff, to talk about how it's going to change from the parent parabola if we were to graph this thing. So the extra stuff in this first equation here is the +1 that I have. When I have that outside of what I'm squaring, since for parabolas I'm talking about x being squared, when I have that outside, that means I'm going up however many units it says. So up 1 for this, if I'm adding 1. If I have subtracting something outside of what I'm squaring, that means I'm going down that number of spaces, which in this case is down 1. If I have +1 inside of what I'm squaring, so that's inside of the function, just like inside of the absolute value, that means I'm moving left, and I'm moving left 1, since I have 1 there. If I'm subtracting 1 inside of what I'm squaring, so inside of the parentheses, just like inside of the absolute value, that means I'm moving right 1. If I see a negative in front, so I have a negative coefficient, that means I have a reflection, just like with the absolute value, reflection over the x-axis. And if I see a negative inside of what I'm squaring, that means I have a reflection over the y-axis. And as you can tell, that doesn't change anything. It doesn't really change anything because this is really equal to x to the second power. It's x squared. So it's just the parabola. It's just the parent parabola, I'm sorry. So having a negative inside doesn't change anything, really. If I have a reflection over the y-axis, since it's symmetrical, a parabola is symmetrical, vertically speaking. All right, for this, I see a 3 as the coefficient, which means, and I'm going to talk about, instead of vertical stretch and vertical shrink, we're going to talk about, for parabolas, the opposite, horizontal shrink and horizontal stretch, because it's hard to see what's vertically happening with a parabola, since it's exponential growth. Instead of, like, with an absolute value is easy to see, but with this, it's not going to be. So we're going to talk about it as what's horizontally happening. So if I see a 3 in front, that's a vertical stretch of 3, but a horizontal shrink of the reciprocal, so of 1/3. And then if I see a 1/3 in front, that's a vertical shrink of 1/3, but a horizontal stretch, the opposite of, instead of 1/3, the reciprocal of that, of 3. So it's going to horizontally stretch if I have a fraction in front. And if I have a number greater than 1 in front, it's going to be a horizontal shrink. So you're going to see it get more narrow, the parabola. All right, so let's talk about what's the transformations for these examples. Well, first off, I have this negative in front for the first example. That means a reflection over the x-axis. Then I'm going to talk about the next transformation I see, which is this 3 here. And that tells me I have a horizontal. I want to talk about what's horizontally happening now. So that's a horizontal shrink of 1/3. This plus 7 inside tells me I'm moving left 7. And then the minus 2 at the end tells me I'm going down 2. For the next equation, I have 1/4 in front. That tells me I want to talk about what's horizontally happening. So that's a horizontal stretch. When I have a fraction, it's going to be getting horizontally bigger. Horizontal stretch, I did not spell horizontal right. Stretch of 3. This plus 3 inside tells me I'm moving left 3. And the plus 6 on the outside of what I'm squaring, that tells me I'm going up 6. All right, so that's my transformations. Next, I'm going to talk about vertex form. So this is a really important form for parabolas. Vertex form is y is equal to a times x minus h squared, so minus h squared, plus k. And when I have this form for a parabola, I know that the vertex of the parabola, talking about the transformations, looking at what I just talked about, that number that I'm subtracting, h, is going to be so the number that I'm subtracting is going to be my x value in my vertex, and the number I'm adding on the outside is going to be my k value in my vertex, so my y value in my vertex, I'm sorry. So h is going to be the x value in my vertex, k is going to be the y value in my vertex, because h is telling me how I'm moving left and right, and k is telling me how I'm moving up and down. All right, so first, for graphing using transformations, there are 2 steps to doing this. The first thing I'm going to do is I'm going to find that vertex. So I'm going to find the vertex using the transformations, or I can use vertex form to figure it out. The second step is I'm going to make a mini table. So a little mini XY table, and then I'm going to use the line of symmetry, which I know goes through the vertex, to plot the other side of the parabola. Okay, so what I'm going to do here, and I changed it on your sheet, so it should say 2x plus 1 and minus 3 on the outside. What I'm going to do is I'm going to find the new vertex. So that's my step 1. Step 1, find the new vertex. So to find the new vertex, I have to look at the transformations of what's happening up and down and left and right. So I'm looking at what's happening inside what am I adding to what's inside the parentheses? That's going to tell me how I'm moving left and right, and this tells me I move left 1. And then this minus 3 on the outside tells me I move down 3, because I'm concerned of how I'm moving left and right and up and down. So left 1, down 3, that tells me my new vertex is going to be at negative 1, since I'm moving left 1. Down 3 tells me I'm moving 1, 2, 3 down, which is negative 3. If I'm starting at 0, 0, which is the parent parabola. Moving left 1, down 3. So started here, moved left 1, down 1, 2, 3. And I ended up here. This is my new vertex. Erase that so it doesn't confuse you. The next thing that I'm going to do, or the other way that you could have looked at this is you could have rewrote what you originally had. So you could have wrote it as y is equal to 2 times x, and then to see what you're subtracting, you change that addition to, well, I know I'm actually subtracting negative 1 inside the parentheses and squaring, which tells me that my h is negative 1. That's the thing that I'm subtracting, so that's what I see here. And then the minus 3 that's like plus negative 3. And that, if you look at the vertex form and compare it, tells me my y value in my vertex. Okay, and the next thing I'm going to do is I'm going to find the two other points to the right of this vertex. So this is my vertex. Whoops. This is my vertex. And I know it's going to be a minimum. Well, I know it's going to be a minimum because I don't have a negative in front, but we can talk about that later, actually, when we see what it looks like. And then the next thing I'm going to do is, so that takes care of step 1. And the next thing I'm going to do is take care of step 2, which is to create a mini table. So a little table with 2 points to the right of that vertex. So I'm going to pick x is 0, and I'm going to pick x is 1. For x is equal to 0, I just plug it into the equation. I have y is equal to 2 times 0 plus 1 squared minus 3. That's 2 times 1 squared, which is 2 times 1, which is 2. 2 minus 3 gives me negative 1. And then for x is equal to 1, I have y is equal to 2 times 1 plus 1 squared minus 3. That's 2 times 2 squared minus 3. 2 squared is 4, so I have 2 times 4 minus 3. That's 8 minus 3, which is 5. So 1, 5. And then I plot those 2 points, 0, negative 1, and 1, 5, 1, 2, 3, 4, 5, right here. And that is the right-hand side of my parabola. I know the line of symmetry is going to be through the vertex. So it's the vertical line that goes through the vertex. That's my line of symmetry. So that's the line of symmetry. And that line is x is equal to negative 1. So I can use that line of symmetry to find my other points on the left-hand side. Well, I know this point is 1 away on the right of that line of symmetry, so I have a point 1 to the left of that. And that's the reflection of the original point. This point and this point are reflections over that axis. And then I'm looking at this point, that's 2 away from the line, so 2 to the right, so I'm going to go 2 to the left, and I'm going to end up on this point here. I'm going to connect this and see that I have, well, I didn't connect that right. I'm going to connect that and see that I have, it's symmetrical on both sides of that line of symmetry. So, just to clarify one extra thing here, I have to talk about the vertex as being a minimum or a maximum. And in this case, it is a minimum, which, to be clear, because I knew it was going to be an upwards parabola, so I knew my vertex was going to be on the bottom of it. It was going to be a minimum. Last thing I want to talk about is the domain and range of this thing. So the domain, all my x values that are included, that's negative infinity is the lowest x value to positive infinity is the highest x value. And then the range is, I'm going from the smallest y value is -2, and that's included, so I put a bracket on it. And then that goes all the way up to positive infinity is included for y, for the y values included in this parabola. All right, so that's how to graph a parabola given an equation. Next, we're going to talk about how to write an equation given a graph. So the first step to doing that is we're going to find the vertex. And the vertex is h comma k if I have vertex form. So h is the number that's being subtracted inside the parentheses. K is the number that's being added on the outside of the parentheses. And then step 2 is to plug in the vertex and another point into vertex form and solve for a. All right, and then the last step is just going to be to rewrite the final equation, or to complete the final equation. All right, so looking at this graph, just looking at it, I want to say, just looking at it, what do I notice? What do I know I'm going to have in my equation? So just looking at this graph, I know I have since this is really horizontally stretched, it's really wide, I know that I have a fraction because it's horizontally stretched, so that's a fraction coefficient. Since I see a horizontal stretch. I also know, just looking at it, that the vertex, I know the vertex is 2, 3, which tells me my h is equal to 2 in my vertex form, and my k is equal to 3. So the number that I'm subtracting inside is 2, the number I'm adding on the outside is 3. And then I also know that it's a downwards parabola, so I'm going to have a negative in front, so negative coefficient, since it's upside down. Okay. All right, so what I'm going to start with is that vertex form. I have y is equal to, I took care of the first step. I found the vertex, so I know what h and k are. I know h is 2 and k is 3. I'm going to start with my vertex form, which I know is y is equals to a times x minus h squared plus k. And I'm going to plug in, I know h is 2 and k is 3. So what I really have is y is equal to a times x minus 2 squared plus 3. And then I'm going to take a point. So I plugged in the vertex. I took care of doing that. And I want to plug in another point into the vertex form so I can solve for a, because right now I have an equation with 3 different variables. I have x, a, and y, and I can't solve one equation with 3 variables. I can only solve an equation, one equation with one variable, only one variable. So I want to change this so it only has one variable. And the way that I can do that is, well, I know an x and y pair that goes together. So I know that when x is equal to 6, y is going to be equal to 1. So I can plug in this point here into my equation to get rid of the other 2 variables. So I'm just left with a to solve for. So x, I'm going to make 6, y, I'm going to make 1. I have 1 is equal to a times 6 minus 2 squared plus 3. and then I'm just going to simplify and solve. So I have 1 is equal to a times 4 squared plus 3. 4 squared is 16, so I have 16a plus 3 is equal to 1. I'm going to subtract 3 on both sides. That's going to give me 16a is equal to negative 2. And then I'm going to divide both sides by 16. Careful, don't divide by negative 2 since it's a smaller number. And that's going to tell me a is equal to negative 1 over 8 if I simplify negative 2 over 16. So this is my a. I have my h and my k, so I can finish my equation. So I know y is equal to, well, the regular vertex form is y is equal to a times x minus h squared plus k. I know, again, h or k is 3. I know h is 2. And the last thing that I want to plug in is a is negative 1 over 8. So y is equal to negative 1 over 8 times x minus 2 squared plus 3. This is my final equation. And I'm done.